Okay, we are now on example number 3. Example number 3. Example number 3, we are having a moment. We are having a moment, which is 10 kilonewton meter. We are having an inch. Then we are having a point load. The distance between here and here is 2 meters. The distance between B and C is 2 meters. The distance between here and here is 1 meter, 1 meter, 2 meter, 2 meter. The first thing we are going to do is just like example number 2, but somehow different because there's a moment here. So we are going to kind of break it down. We'll divide it from the inch. We separate them. We separate this. So draw the free body diagram. You know, this one is going to be a what? It's going to be 2 reaction. This is the upward and the downward. I'm going to have arrow A. I'm going to have HA. So here we are going to have our clockwise moment. So here is point C, but let's leave that for now. This is 2 meter. This is point B. This is 10 kilonewton meter. 10 kilonewton meter. That's the unit for moment. Okay. So this is point C. Let's leave that. So let me draw this part now. This part is we are having a point load here, which is 5 kilonewton. We are having a roller support, which is arrow E. The reaction, we are also having a point load here, which is 10 kilonewton. And here we are going to have a roller support, which is what? Arrow G. Right? So here is 2 meter. 2 meter, 1 meter, this is E, this is F, this is G, this is D, this is 1 meter. So here is 2 meter. Okay, if you look at it in the first video, I assume that this one should be an upward force, right? Now let's take it as a downward force now to show you that you can just assume them anyhow. So let's assume this as a downward force. Or if this one is a downward force, this one will be a what? Upward force. So let's assume that this one is acting this way. So if this one is acting this way, this one will be acting this way. Do you get that? So this is, let's say, HC. So it will be arrow C, HC. You get that? Okay, so now let's solve this beam first. Let's solve beam A, B, and C first. Beam A, B, and C. Let's solve this first. Considering this, first thing we do is to take our what? Our horizontal forces. I assume this to be positive. So it means HA will be positive, while this one will be negative. HC, you can see it's going like this, equals to 0. Then HA will be equals to what? HC. And they are both equals to what? 0. So now the next thing is to take our what? Vertical force be equals to 0. My coordinate upward force is positive. So what are the upward force here? We only have arrow A, then this one is a downward force minus arrow C equals to what? 0. It means arrow A will be equals to what? Arrow C. Then the next thing is to take my moment. So let's take moments now. Moments about what? About A. About A will be positive. Equals to what? 0. So let's take our moment. This is point A, right? We are going to have one force and this moment. And this force is what? Going downward. Then it's going to have what? Clockwise moment. You understand? If you look at the direction of this moment, it's also a clockwise moment. So it means arrow C times what? The total distance, which is what? 4 plus, because it's a clockwise moment, plus, and don't forget when you are considering moment, we don't consider distance because it's already what? Moment. And moment is what? Force times perpendicular distance. That is why you see the unit is what? In kilonewton meter. Equals to what? 0. So 4 RC, I'm going to have 4 RC to be equals to what? To be equals to minus 10. To be equals to minus 10. So RC to be equals to minus 10 over 4. 2 here 5, 2 here 2. 5 divided by 2, RC will be equals to what? Minus 2.5. Do you get that? Minus 2.5. Minus 2.5. Okay, so if it is minus 2.5, you already know that kilonewton, right? So you already know that RC will be equals to what? 2.5. But let's go to RC. RC is a downward force. So it's going to be what? Upward force. So upward force. Do you get that? So now, can we get our RA? Yes, we can get our RA. Our RA minus RC is equal to what? 0. But what is my RC? My RC here is nothing but what? Minus 2.5. If I put minus 2.5 here, it's going to be RA minus into minus 2.5 equals to 0. Minus times minus is what? Plus. So if it is plus, it means when it comes back here, it's going to be what? Minus. So RA will be equals to minus 2.5. Yes. Oh, sorry. That's a mistake. Sorry. ROC is not minus 2.5. It is what? 2.5. This minus is just to show you the arrow, to show you the direction of the what? Of the reactions. Do you understand? Please take note of that so that you will not make such mistake in your exam. You get that? So ROC, ROA minus what is ROC now? ROC will be what? 2.5 equals to what? 0. So ROA is going to be what? 2.5 kilonewton. Do you get that? Please take note of that. The negative there is just telling you that this arrow, the assumption you make is not correct. It should be the opposite side. So if it is downward, it's going to be what? Upward. And that is what I've just shown. Please take note of that. Okay, so now the next thing is to consider beam what? Beam. Please take note of that. Don't make such mistake, please. Okay, beam C, D, E, F, and what? G. So that's the beam we want to consider now. That's the beam we want to consider now. Okay, now, so don't forget that our ROC here is assumed to be what? It's supposed to be what? Upward. So if this one is taken as upward, it means this one should be what? Downward, not upward. Do you get that? So now, what is here is what? Downward force, right? So the first thing we are going to do is to take our summation of horizontal force. Do we have any horizontal force here? Yes, HC, which is equal to what? 0. So let's take summation of vertical forces. With 0, my coordinate here is positive. Okay, so now don't forget this one is a downward force. We are going to have this and this as upward force. ROE plus ROG minus what? Minus ROC. But ROC is what? 2.5. 2.5. Do you get that? 2.5 minus what? Minus 5 minus 10 equals to what? 0. Do you understand? So now, ROE plus ROG, if you sum this together, this plus the minus 2.5 minus 5 minus 10, I think that should be what? Minus 17.5. When you cross to the other side, it's going to be what? 17.5 equation what? 1. Do you get that? So now the next thing we are going to do is what? Is to take our moment. we are going to take moment, and we take moment, we are taking it about what? Point C. So moment about point C equals to what? 0. So if I put my hand here, how many force we are going to have? 1, 2, 3, 4. You get that? So now this one will give us a what? Clockwise moment, anti-clockwise, anti-clockwise. So let's start with the clockwise first. It means 5 times what? 1. 5 times 1 plus 10 times the distance it covers. What is the distance? The distance is what? From here, 2 plus 1, 3 plus 1, 4. Minus, let's start with this, ROG times the total distance. ROG times the total distance. The total distance is what? 4, 5, 6. 6 minus what? ROE. The distance ROE we cover is what? 2. So 2, everything equals to what? 0. Do you get that? So 5 times 1 is 5 plus 40 minus 6 ROG minus 2 ROE equals to what? 0. So 5 plus 40 is what? 45. So 45, it means that 45 minus 6 ROG minus 2 ROE equals to what? 0. If this 45 moves to this other place, it's going to be what? It's going to change to what? Minus. So we are going to have minus 6 ROG minus 2 ROE equals to what? Minus 45. We can multiply 2 by minus, right? So if we multiply 2 by minus, we are going to have 6 ROG plus 2 ROE equals to what? 45. Equation what? 2. Now, if you look at equation 1 and 2, we can solve them simultaneously. Do you understand? And equation 1 is what? ROE plus what? Plus ROG equals to what? 17.5. Equation 1. Equation 2. Let me just arrange them. This ROE here, let me print it. You know, it's positive now. It's positive. So you can first write 2 ROE plus 6 ROG, because addition is commutative, equals to what? 45. Equation what? 2. So let's solve these two equations simultaneously. Let's use can we use elimination method here? Can we use elimination method? For us to use elimination method, probably we have to times equation 1 by what? By 2. So if we do that, this one will be times 2. So it's going to be, okay, let me clean this line first. It's going to be, the new equation will now be 2 ROE plus 2 ROG equals to 17.5 times 2. 17.5 times 2. 17, I'm coming, let me press my calculator, on 5 times 2. So that is 35, right? So now we now have the second, this is still our equation what? 1. So this one will be 2 ROE plus what? 6 ROG equals to what? 45, which is the equation what? 2. So now let's use elimination method. If I subtract equation 1 from 2, this will cancel out this, right? Then we'll be left with this, right? 2 ROG minus 6 ROG. That is what? Minus 4 ROG equals to 35 minus 45. 35 minus 45 is nothing but what? Minus 10. Abi? So this minus will cancel out this minus. So ROG will be equals to 10 over 4. 2 here 5, 2 here 2, which is what? 2.5 kilonewton. How to get that? So our ROG is nothing but 2.5, right? So can we get our ROE now? Yes, we we can get our ROE by substituting 2.5 for any of this equation, either equation 1 or equation what? Or equation 2. But instead of wasting your time doing that, look at this. From this equation 1, I can still get my ROE using this, because ROE plus ROG is equal to what? 17.5, right? So, and I've gotten my ROG to be what? 2.5. ROG is 2.5. So, ROE plus 2.5 equals to what? 17.5. So, ROE will be equals to 17.5 minus what? 2.5. So, ROE will be equals to 17.5 minus 2.5. 17 minus 2, that is 15. So, this will be 15 kilonewton. You get that? So you can see the calculation is very interesting. Leads us to simultaneous equation, and we are able to solve that. I really love that. So you can see everything here is very simple. Please, when you practice, you are going to know all this. That's why I love solving 10 examples. Do you understand? Plenty example will enable us to learn this very well. Thank you. We move to example 4.